Hello and welcome back. At the end of last video, we're going to start looking at the function 2 tangent 1/2 theta. And to really graph this, what I want to do is I want to start by graphing the function tangent of theta, and then we'll compare them. So tangent of theta will cross 0 at 0, 1 at pi fourths, and then shoot off to infinity by the time it reaches pi halves. So it will look something like, oops, didn't mean to do that. It will look something like this, and it does a very similar thing on the other side, going down. So it has this nice S shape to this, and with tangent 2 tangent 1/2 theta, we've got this factor of 2 here, and that's going to stretch our function vertically. So maybe in blue I will draw 2 tangent theta. I hope this is visible. So again, at 0, 0 times 2 is still 0. At pi fourths, instead of reaching 1, we're going to reach 2. And then instead of reaching -1, we'll reach -2, which is -1 times 2. So we have this S function that's a lot taller than it was before. And now we have this 1/2 in here. And what the 1/2 does is it's actually going to stretch our function horizontally. Maybe this is a little bit counterintuitive, but if you imagine, if I plugged a pi into this function, I'm going to get tangent of 1/2, which is where there's an asymptote. So at pi, we are going to have an asymptote. If I try to plug pi halves into this function, well, 1/2 of pi halves is the same thing as pi fourths. And at pi fourths, if we are taking into account the 2, we're going to be way up there. So we've got this asymptote. So the way this will work is we're going to have a much bigger, I'll just draw over top of my things over there, and then on this side, again, we're going to do a very similar thing, and then we'll have an asymptote sort of just off screen there. So this gets stretched up by 2. So instead of crossing through 1, it's going to cross through 2, and at 1/2 theta, we have stretched this by a factor of 2. Let's go through another one as well. So let's graph 1 plus, and I think what I want to do is cosine of 2 theta instead. I think this will be a little bit more helpful. And one thing that we can do is, again, I'm going to graph cotangent theta in red here. So cotangent theta has an asymptote at 0, an asymptote at pi, and it crosses 0 halfway in between. And then we hit 1 and -1 on the way up and down. So we have this S curve in the middle. And 1 plus cotangent of 2 theta, what will happen is if I'm adding 1 to a function, I'm just going to shift the entire thing up 1. But also, we have cotangent of 2 theta, and if I have 2 theta in here, what's going to happen is our function is going to shrink down. So again, if you can imagine that I plug pi halves into 1 plus cotangent 2 theta, well, I'm taking cotangent of 2 times pi halves. Well, that's just cotangent of pi, which is undefined there. So I have an asymptote here. So we can kind of see that we've shrunk our period down, and we're also shifting everything up 1. So instead of having a cotangent function that looks like an S kind of like this, we're going to shift that up by 1. So now our cotangent function will start here, and it will come down that. So we still have that S shape, but in the middle, where we would normally be crossing 1, we've shifted it up by 1 unit, and the period of our function has been cut in half with this 2 there. And let's summarize a little bit of this. So if we're looking at A tangent B theta plus C, so plus some constant, or A times the cotangent of B theta plus C, the only difference here being whether or not we're looking at a tangent or cotangent, the period of our function, just like the period of a sine function, is going to be pi divided by b. Whereas with a sine or cosine, it was 2 pi divided by b, because that's the usual period. Here, the usual period of a tangent or cotangent is going to be pi, so we still end up dividing by b. It's going to chop it. Up. A is going to shrink or stretch the tangent or the cotangent vertically. So if we multiply by 2, we are stretching it up. We're stretching the whole thing. If we multiply by a number that's less than 1, say 1/2, we're going to shrink it down. And for instance, if we multiply by a negative number, it will flip the whole thing over. All of the positive numbers become negative, all the negative numbers become positive. C, if you add c to a function, we just shift it by c vertically. So if you add 1, just like up here, we shifted our whole function up 1. If we were to subtract 1, we would shift the whole thing down. And tangents are going to have asymptotes at odd multiples of pi halves, and cotangents are going to have asymptotes at multiples of pi, with a caveat. The asymptotes are going to change depending on what b is. So a better way to remember exactly what this is, to remember where the asymptotes are, tangent does not have an asymptote at 0. It will never have an asymptote at 0. Cotangent does have an asymptote at 0. So for me, the easiest way to tell, am I looking at a tangent function or am I looking at a cotangent function? Is there an asymptote at 0? If yes, then it should be a tangent function. If not, it is a cotangent function. So let's do an example where we find the equation for one of these guys. So here, again, so what I just mentioned is the asymptotes. So no asymptote at 0. So if we have to choose between tangent and cotangent, we want a tangent function, not the cotangent function. We can look at the period of our function as well. So how long is one period going to be? Well, this right here is the length of one period, and that is too long. So our period, which is going to be equal to 2, the period of a tangent function is pi divided by b. So solving for b here gives b is going to be equal to pi halves. So we know what b is. Let's figure out a. So what we notice is that our tangent function is increasing like normal. So since we're going up, all the positives are where the positives should be, all the negatives are where the negatives should be. So a is positive. The tangent function should be increasing. So since it is increasing, our a is going to be positive. However, we know that if we look at our tangent function, directly in between the asymptotes, we should cross 0. And in between 0 and an asymptote, we should be at 1. but we're not at 1. We're at exactly 1/2 of that. So a is going to be equal to 1/2. And since we are hitting 0 directly in between the asymptotes, c is also equal to 0. We haven't shifted this up at all. So halfway in between asymptotes should be 0, and it is 0. So we know all of our ingredients. So this function here is going to be 1/2 times the tangent of pi halves theta plus 0, but plus 0 doesn't really add anything. Let's do one more example, and I will make this up right here. So we'll have an asymptote there, out here at pi. We'll have our second asymptote at 2 pi. So we'll just draw one period of this function. So I'm going to say that we'll be up here at 4, 2, 1. Okay, so we have our cotangent. Or sorry, we have our tangent function or cotangent function. I may have just spoiled it, but we have to decide whether or not this is a tangent function or a cotangent function. And we can see that we have an asymptote at 0. So this is not a tangent function, but it is a cotangent function. Next up, we can look at the period of our function. And the length of this period of our function starts from 0 and goes all the way to 2 pi. So that's going to be 2 pi long. So the period, which is equal to 2 pi, is going to be pi over b. So by solving for b here, we get that b is going to be equal to 1/2. Okay. So now we have to figure out a and c. And normally, a cotangent is going to be decreasing. So what we've done is, instead of being decreasing, we are increasing. So the difference between increasing and decreasing is going to be a positive factor. So we know that a is negative. Okay, so that's the first step. Also, we can see that halfway in between the asymptotes, a cotangent function should be at 0. But we have scooted up our cotangent function by 3. So we know that c is going to be 3. And then the last thing is to identify what exactly is a. We know a is going to be a negative number. So if I were to subtract 3 and actually scoot this down, where would my function be? Maybe I'll draw that in red here. So if I were to scoot this down 3, if I was at 4, I would be at 1. And if I was at 2, if I scoot that down 3, I would be at -1. So my function kind of looks like this. So this is scooting our function down 3 so that we can figure out what a is. And we know that a cotangent function would normally have a height 1 and a height -1. So we haven't stretched our function at all. Normally it passes through 1 and -1, halfway between the center and the outside. So a is in fact going to be equal to -1. We haven't stretched it at all, just flipped it over. So our function is going to be negative cotangent of 1/2 theta plus